Welcome to day 2 of substitution. Hopefully you guys are starting to get the hang of what it means to substitute in an expression or a variable or a number for another variable. We're going to go ahead and finish up the examples at the bottom of this page and then try that other word problem out. If you take a look at this first example, you might notice that the difference between yesterday's notes and today's is that both of these equations are set equal to the same variable. And so unlike yesterday, we're going to have the option to do pretty much either substitution, where we might take the 2x plus 4 and substitute it in for the bottom y, or we might take the negative x plus 1 and substitute it into the top y, but either way, either substitution is going to work. Another way of looking at this relationship is if we say y is a and we let that whole expression on the right be b, well, I have another y in the second equation, but a different expression on the right. But if b and c both equal a, then the conclusion is that b has to equal c, which would be the green and red box parts right now. So I'm going to go ahead and keep it simple and substitute that top expression into the y in the bottom equation. And so I'll keep the right-hand side of the equation the same, and I have negative 1x plus 1. But now, instead of setting it equal to y, I'm going to set it equal to what y equals in the top equation, which is 2x plus 4. From here, it's solving an equation with variables on both sides. I'd recommend get rid of the variable term first, so I could subtract 2x from both sides, or I like to keep my variables on the left-hand side, so I'm going to get rid of them on the right. And so I add 1x to both sides, I get 3x plus 4 equals 1. If I subtract 4 from both sides, then I get 3x equals negative 3. And if I divide both sides by 3, I get x equals negative 1. So my x-coordinate in the ordered pair, the point of intersection, is going to be x equals negative 1. And now I need to solve for the y. So I can plug the x-coordinate into the top equation or the bottom equation. To stay consistent with yesterday's notes, I'm going to go ahead and keep the top equation. So y equals 2x plus 4. Then becomes, when I do the substitution, y equals 2, and then the x-coordinate I got is negative 1 plus 4. Simplifying this expression on the right, I get y equals negative 2 plus 4, so y equals 2. And then the equation I didn't use to solve for y, I'm going to go ahead and do my test with. So y equals negative 1x plus 1. So instead of y, I'm going to plug in the coordinate I got, which is 2. And we're wondering, does that equal negative 1x, negative x, so negative 1 times negative 1. Plus 1. And if you go ahead and simplify, negative 1 times negative 1 is 1. 1 plus 1 does equal 2. So I've solved for the correct ordered pair. Let's try it one more time. So if you take a look on this problem, this system, I'm actually given x's are equal to certain expressions. And so just like the other example, I can replace the bottom x with the top expression for x, or I can replace the top x with the bottom expression for x. So to switch things up, I'm going to go ahead and do the one that's currently highlighted. So I'm going to keep the right-hand side equal to negative 3y plus 7. But instead of x, I'm going to substitute in what x equals, which is negative 2y plus 5. And from here, it's solving a equation with both variables on both sides. So I'm going to add 3y to both sides. I get 1y plus 5 equals 7. Subtract 5 from both sides, y equals 2, and I'm done. Doing a back solve into either equation, I can go the bottom or I can go the top. I'll go ahead and do the top. So x equals negative 3y plus 7. X equals negative 3 with the y we just got is 2 plus 7. And so x equals negative 6 plus 7, which is 1. And to complete the check, the test, we would use the equation not used to solve for x, which is x equals negative 2y plus 5. Instead of x, I'm going to substitute in the one that we got for x. Negative 2 times, instead of y, we got y equals 2, and then plus 5. And from here, we simplify. So 1 equals negative 4 plus 5, and indeed it does, so we got the correct ordered pair. Let's take a look at one word problem application. Yesterday we looked at the first word problem example. Today let's look at the bottom word problem, which we have seen before. It's just that instead of graphing, we're going to go ahead and use substitution to solve it. Charlie and Mara are babysitters. Charlie, he gets $10 plus $6 per hour. Mara, she charges $8 per hour. There's no initial fee. And so y is going to represent the amount earned after X number of hours. And I'd like for you to find out how many hours they would both need to work in order to earn the same amount of money. So equation 1, we can have B Charlie. And in this equation, y equals the amount he earns is going to be $10 plus however many hours he works times $6 per hour. And for Mara, the amount she earns, y, equals 8 times the amount that, or the number of hours that she works. And so from here, this should look super similar to something you just saw. We can take the 8x and plug it into the first y, or we can take the 6x plus 10 and plug it into the second y. Either way, you'll get a true statement. And so in the second equation, I'm going to keep the 8x the same. And instead of y, I'm going to plug in the 6x plus 10. And from here, it's an equation with variables on both sides. I want the variables on one side, so I'm going to get rid of the 6x on the left. And I get 10 equals 2x. And then I can divide by 2 to get x equals 5. Now, x is the number of hours, and so 5 hours would be the number of hours they need to work in order to earn the same amount. Now, we can back solve and plug the 5 into either equation. So, for example, y equals 6x plus 10. Y equals 6 times, instead of the x, we plug in the 5, plus 10. 6 times 5 is 30. Y equals 40 then when we add the 10. And so they supposedly earn $40 if they both work 5 hours. We can test that pretty easily by looking at Mara's equation. And if we have y equals 8x, does 40, the y, equal 8 times 5? And that's some pretty simple math. 40 equals 40, it's true. And so we've identified the number of hours and the number of dollars that they would work and earn to be the same. My only other comment is please be sure that you keep track of the sides of the equation. So for example, had I not subtracted 6x from both sides, I'm totally allowed to subtract 8x from both sides, for example. So I'm going to go ahead and write over the negative 6 for a moment. I just need you to see that this equation would have become negative 2x plus 10 equals 0. So that's still a two-step equation where you would have needed to subtract 10 from both sides. Negative 2x equals negative 10. Divide both sides by negative 2, and you'd see that x equals 5 either way that you solve that equation. Again, just please be sure that you keep track of the sides of the equation.